Hi dear friends, good morning to all. Myself Bhavsep Sorone, Assistant Professor Department of Chemistry, Gokhale Education Society's Arts, Commerce and Science College, Jawar, District Pargar. Dear friends, in the last part of the video, we have seen the phenomenon called as nuclear transmutation. Dear friends, in that part of the video, we have seen that the one element can be converted into another element by bombarding it with the fast moving particle like proton, deuterons, alpha, gamma particles with the emission of some particles called as ejector particle. But it is possible to convert one element into another element. Then the element which is bombarded by a fast moving particle is called as target element, and the particles used for bombarding the parent element called as projectile, and the newly formed element in this nuclear transmutation is called as daughter element, or it is also called as a recoil nucleus, and the other ejected particles or the emitted particles are called as ejected particles. So these are the terms which was involved in the nuclear transmutation, or which is also called as the atomic transmutation. Nuclear transmutation or the atomic transmutation is the simply conversion of one element into another element by bombarding it with the fast moving particle with the ejection of some other particle. So this phenomenon is called as the nuclear transmutation. Dear friends, in this part of the video we are going to discuss about the nature of newly formed element that we call it as the recoil nucleus. So what is the nature of recoil nucleus? That is also important. If this recoil nucleus, which is also called as the daughter element, is stable, then this phenomenon is simply the natural radioactivity. But what happens many times, this newly formed element or a recoil nucleus is not stable, and it itself becomes unstable after its formation, and it again emits some radiation spontaneously, so it shows the radioactivity. So today in this part of the video we are going to discuss about the nature of this recoil nucleus called as artificial radioactivity. So in this artificial radioactivity, actually before discussing the artificial radioactivity or before discussing the definition of artificial radioactivity, first of all we will discuss its a discovery. So here initially it was observed by the scientist Irene Joliot Curie and F. Joliot in the year of 1934 that when the elements like aluminium, boron or the magnesium was bombarded by means of alpha particles, then in addition to neutron the positrons also emitted. Actually expected is that the neutrons should be emitted as ejected particles, but they have observed that in addition to neutron the positrons are also emitted. After this study, they also observed that the emission of neutrons by this parent element or the target element was stopped, but the emission of positron was continued even after the removal of source of bombarding particle. It's very important that actually expected thing is that whenever we will remove the source of bombarding particle, means the projectile, then the emission of particles should stop. But here they found that the emission of neutrons stop with the removal of source of bombarding particle, but the emission of positron was continued even after the removal of source of bombarding particle. I hope you can understand about the difference between these two. Actually expected is that the emission of particles should be continue till the presence of source of bombarding particle, and it should get stopped with the removal of source of bombarding particle. But here they found quite different, that the emission of neutron was stopped but the emission of positron was continued. Emission of positrons was observed even the source of bombarding particle was removed. So I hope you will be able to understand the main difference of this. And after this observation that neutrons stopped but the positrons were emitted even after the removal of bombarding particle source, then they pointed out, or they have concluded, that the whatever recoil nucleus which is formed in this nuclear transmutation, this recoil nucleus is unstable and it emits this positron, and that's why this recoil nucleus which is unstable, and as it emits particles like a positron, it means that it is radioactive in nature. It means it shows disintegration. It means it shows radioactivity. So this is the important thing. So we can make one conclusion, that here the parent element aluminium, boron, magnesium, these are the parent element. Alpha particles are the projectile, neutrons are the ejected particles, and the recoil nucleus is radioactive. It means that the whatever two particles are emitted here, one is the neutron and another one is the proton, but neutron emission of neutron gets stopped with the removal of source of bombarding particle, but the emission of positron was continued even after the removal of source of bombarding particle. It means that neutrons are emitted by parent element or the target element, but the positrons are emitted by what? These positrons are emitted by means of an recoil nucleus. So I hope we will be able to, because in the earlier lecture we have discussed that suppose this is the target and it is bombarded by means of an projectile, then it gives the formation of what? It gives the formation of recoil nucleus, plus it gives the formation, or it emits the particle called as the ejected particle. So what happens in this artificial radioactivity? Initially this target get converted into recoil nucleus. For that purpose it requires the bombarding of what? It requires the bombarding of this P1, means projectile. But whenever this projectile was removed, the neutron gets stopped, or the emission of neutron gets stopped, but the positrons were continually emitted by means of sample even after the removal of source of bombarding particle. It means that this target is responsible for the emission of what? It is responsible for the emission of neutron, and this recoil nucleus is unstable and it is responsible for the emission of what? It is responsible for the emission of positron. I hope you can understand, and that's why this emission of positron was continued even after the removal of what? After the removal of this projectile source or the source of bombarding particle. So this is the simple case that can be studied here, and this nature of recoil nucleus is unstable, and that's why it shows the radioactivity. It means that we have converted stable element like aluminium, boron, magnesium into unstable recoil nucleus, and that's why we have made non-radioactive element into radioactive element, and that's why this process is called as the artificial radioactivity. And the phenomenon in which this non-radioactive nucleus converted into radioactive nucleus is called as the artificial radioactivity, or we can say that phenomenon in which recoil nucleus becomes radioactive, becomes unstable, is called as simply artificial or induced radioactivity. So in the next slide we will discuss about its nature, or before discussing the nature we will discuss about the definition. So based upon the previous slide, we can see here, based upon the previous slides, we will be able to define the definition of this artificial radioactivity. That's why the artificial radioactivity can be defined as the conversion of stable nucleus of one element into unstable nucleus of another element by bombarding it with the fast moving particles called as the projectile, and these projectiles are proton, neutron, deuteron or alpha particle, is called as artificial radioactivity, or it is also called as induced radioactivity. So definition of this artificial radioactivity or induced radioactivity is very simple. Conversion of the process of conversion of stable nucleus of one element into unstable nucleus of another element by bombarding it with the fast moving particles is called as artificial radioactivity or induced radioactivity. So here this recoil nucleus is also called as the daughter nucleus, which is formed here, and it is unstable. As it is unstable, so definitely it will show disintegration spontaneously. It means it will undergo, or it means it will show radioactivity. It will show radioactivity spontaneously. It means it emits the radiation. It emits the particle. So what type of the particles are emitted by these radioactive element? That type of particle emitted by radioactive element, it depends upon what? It depends upon number of neutron and proton present in the nucleus of daughter nucleus, or in the nucleus of daughter element, or in the nucleus of recoil nucleus, or the newly formed element. So how many number of protons and the neutrons are present in the nucleus of recoil nucleus or in the nucleus of daughter element, that number will decide the type of particles emitted by radioactive recoil nucleus. So here this is the important, it means that it depends upon the N by Z ratio. So here in the next part, or in the next slide, we will discuss about the what type of the particles are emitted by recoil nucleus, which is unstable. So in the first case, we will discuss about the number of neutron and the proton. It means N by Z ratio. N is the number of neutron and Z is the number of proton. So neutron to proton ratio of daughter element, if or daughter nuclei is less than or equal to 1, then it attains a stability spontaneously by emitting a positron, or it attains a stability by emitting positron spontaneously. So here we will discuss this with the help of some example, how it emits the positron. For that purpose, we will discuss about whether the N by Z ratio is less than 1 or equal to 1, because we are discussing both the cases, less than 1 and equal to 1. In the first case, we will discuss about neutron to proton ratio of this. Neutron to proton ratio is what? This neutron to proton ratio of recoil nucleus and not the parent, keep in mind. So here you have to consider the neutron to proton ratio of recoil nucleus and not of the parent element or the target element. This is the target element bombarded, beryllium is the target element bombarded by helium as a projectile. It gives the formation of recoil nucleus. So this recoil nucleus is silicon. So this silicon having mass number 27 and atomic number 14. So the number of proton means the value of Z will be 14. Are you getting this? And number of neutron means the difference between 27 and 14. So 27 minus 14 will be the number of neutron, means that is 13. 27 minus 14. So here in this silicon, which is indicated by star, number of proton is 14 but number of neutron is 13. So 13. So here N by Z ratio is 13 by 14. So definitely it will be definitely less than 1 point something, that will be the value less than 1. So this silicon 27 having n by z ratio is less than 1. So this recoil nucleus is unstable, and that's why it emits the particle spontaneously, and it emits the particle, that particle is called as the positron, and itself get converted into another stable element, aluminum 27. So this is, so it means that whenever the n by z ratio of any recoil nucleus is less than 1, then it always emits positrons spontaneously. It always emits positrons spontaneously. Instead of this, if the n by z ratio, if the n by z ratio of recoil nucleus is equal to 1, here we will discuss about the n by z ratio of recoil nucleus, how it is equal to 1, we will discuss with the some example. Here this is the target element bombarded by the again alpha particle, helium particle, so it get converted into what? Phosphorus. So this is the recoil nucleus. So what is the number of proton and the neutron in this phosphorus? Phosphorus having atomic number 14 means here in this case z is equal to what? Z is equal to 15. So value of number of proton will be 15, and the difference between these two, mass number minus atomic number, 30 minus 15 is the number of neutron. So definitely number of neutron means value of n will be also 15. So 15 divided by 15, it means that, so definitely this will be equal to 1. So here the n by z ratio of this recoil nucleus is exactly equal to 1, and in this case it is again unstable, so it emits the radiation spontaneously, it will undergo disintegration, it will show radioactivity, and it emits the particle again positron, and this phosphorus 30, which is the radioactive, which is unstable, get converted into silicon 30, which is stable element. So conversion of, again, that is nothing but stable into unstable spontaneously. So what is the thing here? Whenever the n by z ratio of any recoil nucleus of the daughter element is less than or equal to 1, then it always emits positrons spontaneously. Instead of this, if this n by z ratio of recoil nucleus, okay, let me achieve this first. Instead of this, if the n by z ratio of daughter element of the recoil nucleus, n by z means number of proton to number of neutron to number of proton in the nucleus of daughter element or in the recoil nucleus, is greater than 1, then it always emits electron, or it always attains stability by emitting the electron. In the earlier case, whenever the n by z ratio was less than or equal to 1, then it was emitting positron. In this case, if the n by z ratio of daughter element is greater than 1, then it attains stability by emitting electron. We will discuss with this one example here. Suppose the target element nitrogen 14 is bombarded with the neutron, fast moving particle neutron, then it will be converted into recoil nucleus carbon 14. So this is the recoil nucleus. N by z ratio of this 6, carbon 6. So carbon having atomic number 6, so number of proton will be 6. So definitely number of J value of Z will be, that is 6. Again, number of neutron, that is mass number minus atomic number. Mass number is 14. 14 minus 6, so definitely that is 14 minus 6, so the number of neutron will be 8. Neutron to proton, that is nothing but the 1 point something. So here n by z ratio of this carbon 14 is greater than 1, and this, whenever this nitrogen 14 bombarded by nitrogen, it get converted into carbon 14, but this carbon 14 is unstable and it has n by z ratio greater than 1. It has n by z ratio greater than 1. That's why it attains stability. By emitting a particle called as electron, and itself get converted into stable element nitrogen 14. So whenever the n by z ratio of any daughter element or the recoil nucleus is greater than 1, then it always emits electron. And if the n by z ratio of any daughter element of the recoil nucleus is less than or equal to 1, it always emits positron. Again, remember that if the n by z ratio of recoil nucleus is less than or equal to 1, then it always emits positron for stability or to attain stability. And if n by z ratio of any daughter element or the recoil nucleus is greater than 1, then it always emits electrons to attain stability. So next is the Q value of nuclear reaction. What is the Q value of nuclear reaction? How can we calculate it? Actually, it is observed that whenever the nuclear reaction takes place, there is always a rearrangement of particles in the nucleus of the atom. During the rearrangement of nuclear particles of the atom in the nucleus, what happens? There is always change in the energy of the nucleus. So during this nuclear reaction, either the energy is liberated or energy is taken, and that energy which is liberated or taken up in a nuclear reaction is called as the Q value of nuclear reaction, just like the chemical reaction. Either energy is liberated or the energy is absorbed. So whatever amount of energy is liberated or the energy is taken up in a nuclear reaction, that much energy is called as the Q value of nuclear reaction. This nuclear reaction involves the change in composition of the nucleus. Change in the composition of the nucleus, it means that during the nuclear reaction, the number of particles present in the nucleus get changed. Means during this nuclear reaction, the number of protons or the number of neutrons may change. So this is called as the change in composition. So here energy changes in the nuclear reactions are very high as compared to chemical reaction, and these are in the order of million electron volt, because the energy change in the chemical reaction is in the order of electron volt, while energy change in the nuclear reaction are very high, and these are generally in the order of million electron volt, too much high than the chemical reaction. Again, the Q value of nuclear reaction can be calculated from the energy and mass of the nuclei and particles involved in the nuclear reaction. It means that whenever you want to calculate the Q value of any nuclear reaction, then we have to consider the energy as well as mass of all particles involved in nuclear reaction. So this is nothing but the way by which we will be able to calculate the value of energy liberated or taken up in a nuclear reaction, that is called as the Q value of nuclear reaction. So how the Q value of nuclear reaction can be calculated, and what will be the significance of Q value of nuclear reaction, that can be studied in the next part of the video. So friends, in the next part of the video we will discuss about the actual determination of the calculation of Q value of nuclear reaction and what will be the significance of Q value of nuclear reaction. Thank you.